using rule of us. The thing is that we say if we want to use pole placement to design our controller, we only deal with pole location, which means we only deal with time constant, damping ratio, and natural frequency. But we have no idea about the zeros. So in order to compensate for those kind of drawbacks, we would like to use rule of Hus to do the design. So when we do the rule of Hus design, step 1, we need to identify, what do I say? Poles and zeros, open loop, location, and we need to know those two things. If we are having a second order system, if we have a first order system, we need to know the tau. So with those two things, we know where our open loop poles and zeros are going to be located. So we start from open loop. Once those things is identified, then we know closed loop. That is something we know because if we know the damping ratio, we know whether it's going to be 45 degree, 30 degree, 60 degree, whatever you want to spacebar, depending on your damping ratio. For the omega n, that is depending on how fast your system is going to respond to your input. So combine zeta and omega n, we should be able to find out where we're going to put our zeta omega n along the x-axis. So that is how we determine which region is going to contain our closed loop poles. But when we draw closed loop poles on S domain, what do we spacebar? We always spacebar. Based on those configuration, we only specify the poles of the worst scenario. We never say anything better. We always want to have anything better than the one we specify over here. But when we do the S-plane design, we always have everything as our worst scenario. So anything within this region is better than the specification. So that is the first thing we need to know. Second thing, before we move on, because the next part we're going to deal with angle criterion and magnitude criterion, those kind of stuff. But before we move on, let's say something before we start. So let's say we have closed loop poles over here, and we say we want to have our closed loop poles over here and over here. So those two locations, before we start. So when we have pole at the red cross over here, what does that mean? K equals to 0 for this kind of configuration. And if we start to approximate to those two, we are increasing our gain, system gain. So if our gain becomes infinite, it goes to, well, it may be 90 degree, maybe 180 degree, but whatever we want to do. Those two positions are somewhere on the trajectory we must pass through. Does that make sense? The K, when we increase the K, the trajectory must pass this point and this point. That's a goal. So in order to make our trajectory pass this one and this one, our zero needs to be designed accordingly. So those are the method. What we call this method, rule of Hus controller design methodology. Does that make sense? Do I need to explain Chinese? Yes. Okay. So